Hydroelectric dams are important because they provide power for people and communities for which it has been built for. Yes, it takes around 4 to 7 years to build a dam, depending on the size, but for the power it provides, it's worth it. The smaller the dam, the less time it takes to build. The time frame it runs from the moment the project installs to the moment they open it for public. While worldwide these dams make up 20% of our created electricity, we may need to raise that amount we have before we lose the earth we build these dams on. It may damage the environment around it, but like Norway, more places around the world should be making 99% of their energy with hydropower to preserve our environment.
While there are many parts of the dam, there are 4 main components: the dam, turbine, generator, and transmission lines. The turbine works by taking kinetic energy from water that it catches and turning it into mechanical energy, while the generator converts the mechanical energy into electrical energy. The transmission lines take electricity and transport it to homes around the community in which it has been placed. The amount of electricity that a plant makes depends on 2 main factors: how far the water falls and the amount of water which is contained.
Dams generate power by using the force of water from one level to another. So the level of our Mactaquac Head Pond is 133 feet above sea level, and where the water comes out from each generator is about 15 feet above sea level. So we have about 110 foot of difference between the 2 levels, and that's the water pushing down and driving the generator itself. We have 6 generators here, and each one of them makes 115 megawatts approximately, and that's where all the work is done, right in the generator itself. We use all of the water that we can to run the generators up to whatever the capacity is for the plant. So our capacity is 80,000 cubic feet of water per second, and once we get over that, then we have to put the rest of the water out through the spill gates. It goes to wherever it's needed. So whatever is needed in the province, a generator just supplies whatever is needed. Well, alternative energy, I believe myself that anything that isn't using fossil fuels is going to be way better for the earth. So if hydro is good, wind is good, the sun is good, solar is good. So I think what it's going to take is not just one of them being a part of the big picture, it's having all of them together, and it makes a system up. Well, hydro is going to always be your cheapest one, but you don't always have fuel 100% of the time, which you do have at a nuclear station. So those guys can run 100% for months at a time, where hydro can only run whatever the water flow is at that time of year. So in the summertime, we can't generate as much because the river flows are down. So, and same in the middle of the winter.
While supplying over 1 billion people worldwide, hydroelectric dams are a very key role in our society. With a worldwide combined output of 675,000 megawatts, they equal the same amount of energy output as 3.6 billion barrels of oil.
There is also another type of hydropower plant called the pumped storage plant. This plant has 2 reservoirs for water, unlike a conventional plant, which only has 1. These reservoirs are called the upper and lower reservoir.
The upper reservoir is like normal reservoir, where water flows through to create electricity. The lower reservoir just takes the water that is exiting the plant into it instead of letting water flow back into the river. Using a reversible turbine, they can pump the water back up into the reservoir.
While it is a man-made structure, it takes advantage of a naturally occurring process where rain falls and rivers rise. Yes, we do lose water every day from UV rays, which break down the molecules, but we gain the equal amount from volcanic activity inside the earth. But a key aspect we need to take into consideration is the environment.
Any type of energy is going to have an environmental impact, especially if you're doing it at a large scale. So when we're talking about hydroelectric dams and solar generated power, wind turbines, windmills, wind farms, or even hydropower, if we're doing them at a large scale, all of them will have some sort of an environmental impact. The potential negative effects, in my opinion, of hydroelectric dams can be significantly higher than, say, solar or wind farms, simply because you're dramatically altering the natural course of a river. A river running in its natural course is the best thing for a watershed. Hydroelectric dams do create new habitat in the sense that they will create a head pond behind the dam, and you can use them to control water level below the dam. Technology is changing, so hydroelectric dams are improving in terms of things like fish migration passages. But overall, from the perspective of somebody who's interested in watershed protection and enhancement, no. Hydroelectric dams are not the way to go.
This is the Mactaquac generating station here, built in 1968. It started up. We have 6 generators here. That's 670 megawatts approximately, and it takes about 80,000 cubic feet of water per second to operate all 6 generators. And we're here for 2 main reasons: is to take up the peak in the morning time when we all get up and go to work. The industrial load for the province stays relatively the same, and what we do getting up in the morning changes the load in the province. And so we take the power from Mactaquac to use for that peak time. And there's 2 peaks, one in the morning and one at night. And another reason that we are here for is the province has to have backup for your biggest generator in the province. So hydro is what does the backup for all our big generators in the province. For the other sections, this being the generating station, and this being the spill gates where the water comes out when there's too much water for the generators. There's 2 of those gates. This is the main dam here. And then over here is what a generator looks like at Mactaquac. So the water comes down. This is your head pond here. The water comes down through this big pipe, which is 177 feet long and 29 feet in diameter, and 14,000 cubic feet of water per second will flow through here, down across these blades here, which turns this shaft, which turns the generator up top, which we'll be seeing later. And then once the water turns those blades, it just goes out to what we call a tail race down below. This here uses about 2 megawatts to run the whole generating station, whereas Point LaPro or something like that uses probably about 60 megawatts. So they have a lot more station service than what we have here. Station service meaning what we use for power to run our generators. This is just for Mactaquac. It's the old equipment. So we can still use this to start and stop our generators here, but the guys usually use the computer system over here.
Probably more efficient.
Well, if you know how to do this, this is faster. So this is the powerhouse. It's 600 feet long, 80 feet wide, and this floor here is 36 feet above sea level, and as we go down, you can go as far down as -20 line below sea level. So once we get out here is where the generators is. This section here is just for, underneath us is the electrical shop, mechanical shops, and lunchrooms, that kind of thing. Once we get out here, this is just all the generator equipment. This is the unit board for the #1 generator. You can start and stop the generator from here, but the guys usually do it from inside the control room. And our generators always turn at the same speed, which is 112.5. And right now this one is making 105 megawatts at 13,800 volts. We'll go down and go inside one of the generators. Woo. So we're going to go down into this room here, which is the what we call the wheel pit for the number 3 generator. We're going to be able to see the shaft in the center, and we'll be able to look up and see the generator spinning. And it's pretty noisy in there, so I will say. Nameplate data for the number 4 generator. The first 4 were all built by a company called Dominion Engineering Works out of Montreal, and so they were built here, put together here. The next 2 generators were built by a company called Leningradsky Militskiy Zavod, which is a Russian company, and they put the last 2 generators in, and this is their toolbox over here. You just put these on, hang them on with come-alongs, and then beat them with a sledgehammer until the nut comes off. It's a real crappy job. There's bolts in there that weigh over 100 pounds apiece, and that's what they used to use, but now they use, they have a mechanical device that sits right on top of the nut and spins it off instead of having to do it by hand labor is what that was. So now it's a lot easier to do. So the next thing we're going to go do is go into the generator wheel pit, and that's when you looked up a little bit a moment ago and see the big generator turning. Well, that's what's in this room. The things I'll point to, because it is noisy in there, I'm going to point to the bracket and the bearing that holds the weight of the machine up. Then I'll point to where the brakes are, and then I'm going to show you the windings where the actual electricity is flowing. That's the bearing. These are your brakes. And that is where the voltage is going. That's 13,800 volts. Of the company that built this is Leningradsky Militskiy Zavod, and that company still exists in Russia today, and they still make generators. They built this one. They were already building generators this size for another company, so it was cheaper for us to buy these ones. So made in the USSR. So this is the main intake area of the dam, what's holding the water back and where the penstocks are for the channel for the water to come down into each generator. So each one of those big bumps that are down across the face of this are the penstocks to the individual units. Up inside there where you see the glass is just a walkway with controls for gates at the very top of that, and we can close those gates off and go in and do maintenance on the generators. So the gate just stopped moving.
That's basically like a man-made waterfall.
That's all it is. Just a door you raise up.
So there's no generators in here?
No generators, no.
So it's just letting some of the water...
We have more water than the generators will take, so then it has to come out here.
Dams play a major role in our lives because they have shown us how to use water for power. They've been around since ancient times, but back then they were used for containing water, whereas now we have converted the idea into a major energy source.
They are important because of how quickly they can respond to peak demands for energy while also being one of the only renewable sources to store energy. Although energy isn't the only thing they keep track of.
Dams can also control the water levels and flooding downstream. They take advantage of not using fossil fuels, which create pollution. They also use a natural process, which is water.
Although energy isn't the only thing they keep track of, there are some disadvantages to dams, though, like the cost of them. They may be upwards of $27 billion, as well as the fish in the river, which may be caught or blocked in their route of passage.
But in the end, it's up to the government to provide us with a renewable source of energy, and dams are a well-renowned source. With 20% worldwide, this is a source of energy we can count on as time moves along.
I can't feel my face when I'm with you.
But I love it.
But I love you, baby. A few hundred homes to... That makes no sense! It literally does not make any sense. For adventure. Take one.